Lesson 3, angles. So before we can go through over angles, we have to go over what a ray is. Now a ray is part of a line that begins at an endpoint. In other words, at a point, and continues without end in one direction. So if we drew a point and then continuing on without end, which means you're going to have an arrowhead here, we would call this ray AB, or we could put capital AB with a little baby ray above it. Order matters when you're naming ray. We cannot switch the order of the letters because the first letter means that's where it begins. It's at this end point, begins at A, and then it continues through point B. When you have two rays that are opposite, we call them opposite rays. That just are two rays that have the same end point, but they go in exact opposite directions. So ray AB and ray AC are opposite rays. So they're just going in exact opposite directions. We have what's called a protractor postulate. This just means if you have a protractor and you have two rays, so say this is X and this is A and this is B, and this ray has degree Y degrees if it goes that way, and this angle B has X degrees. If you just take the absolute value of these two numbers subtracted, so X degrees minus Y degrees, take the absolute value, that's actually going to give you the measure of angle AXB. And whenever you're writing down what the measure of an angle is, you want to put the little m and then the angle in 3 letters. The angle addition postulate, this is a lot like the segment addition postulate from lesson 2. This is just if you have two angles that have the same endpoint, we'll call this angle ABD and angle DBC. That if you add the measure of angle ABD to the measure of angle DBC, you will get the measure of the big angle ABC. If you have an angle that is divided exactly in half, here's an angle, and this ray divides it right in half. So we're going to call this A, B, D, C. Okay, so ABC is an angle. Ray BD is called an angle bisector. Now we have to show that these two are equal, so we'll put a little angle mark there and one there. That just means they're the same. So if the measure of angle ABD is congruent to the measure of angle DBC, oh no, if the measures are equal, sorry. The measures are equal, then the angles themselves are congruent. So when we're talking about equality, we're going to use measures, and if we're talking about congruence, we just use the names of the angles. And that's the end of lesson 3.